Hello, everyone, and thank you for joining us. We'll get started in about a minute. Quite a few people are just now logging in, so we'll just give them a chance to get set up. Hello, everyone, and thank you for joining us. I know that you're very busy and have many things on your plate, and we're flattered that you've chosen to spend the next 45 minutes to an hour with us. We hope that you will find this webinar to be both informative and interesting. The topic of today's webinar is Graph Databases are changing the fraud detection and prevention landscape for financial institutions. This is episode 34 in our Graph Guru series. Next slide, please. My name is David Ronald. I'm Director of Product Marketing here at TigerGraph, and you can see some details on my background there. But more importantly, next slide, please. More importantly, I'm joined by my esteemed colleague, Abhishek Mehta, who's Director of Sales Engineering at TigerGraph. He has a rich background. He's held important roles at McKinsey & Company, Bloomberg, Cisco, also a company called Abismo, where he was a founder, and that company was a natural language processing startup. Abhi has over 15 years experience designing and implementing complex analytics solutions for large companies. He has patents in natural language programming spanning conception-array ontology design, language pattern recognition, and conversion. Abhi joined TigerGraph in February of 2018, initially as a pre-sales director for the Eastern region, but within just a few months was promoted to Director of Sales Engineering. So he's very well qualified for a number of reasons to give this presentation today, and I'm confident that you will benefit from listening to it. Next slide, please. So finally from me, before I pass things over to Abhi, some housekeeping items. Of course, everyone's phone is muted. That's standard practice these days. But please don't take that as a sign that we don't want to hear from you. It's quite the opposite. We want to make this webinar as interactive as possible to ensure that you get the most out of it. So feel free to submit questions throughout the webinar. We'll probably take the questions at the end. The best way for you to submit questions is through the Q&A tab in Zoom, as we've shown there. Second, the webinar is being recorded. Will be sent to you shortly after the webinar ends. We're quite good about getting these webinars archived within about 3 hours. I can't take any credit for that. It's my colleagues in marketing who are very quick to get this uploaded. So we'll send an email within about 3 hours or so. Keep an eye open for that. Within that email, we'll have a link to the archive. It's also shown here. And any additional materials that Abhi feels you might benefit from will be included in that email. Last but not least, if you have any issues with Zoom, it's quite common these days, please reach out to us and we'll do our very best to handle them in a timely manner. So with that, I would like to hand the webinar over to Abhi.
Thank you, David. Hey, everybody. Thank you so much for joining in. And I hope that during these times, you and your loved ones are keeping safe. So wherever you are, good morning, good afternoon, good evening. And as we move toward these stranger times, the topic of this webinar becomes even more important. As you eyeball what's on the screen over here, I will summarize it for you. What we're going to do today is that we are going to talk about various different use cases that we are seeing in industry for financial services. That include credit card, that include money laundering scenarios, bank account, loan applications. So the idea here would be to give you the view of how graph databases are totally changing the landscape of fraud detection, and how this technology has become a centerpiece, a core part of any anti-fraud landscape with your teams that you're setting up. So some key stats for you. It's from 2018. Around $25 billion were the payment frauds worldwide, and 1/3 of them were in the United States alone. Speaking of that, I mean, that's not the only hit what we all get. 15% of US card holders has informed about blocked sales. As you can see, I have bolded this word blocked sales because if the total amount of that was around $118 billion. Now, looking at the scenario where one in the fifth 5 transaction is fraudulent, and most of the cases where 40% of the denied cases were above $250. And when we look at the total cost of fraud to your company, it is way beyond the number. The number 9 billion in US or 25 billion worldwide looks pretty meager. Basically, these are the lost opportunities. People go to point of sale or online, they're trying to do a transaction, but it got invalidated. The reason could be it's very well a false positive. So keeping all of these things in mind, if we start calculating the total cost of fraud, it's combination of things. It's combination of the stolen amount, the money which is stolen from your accounts, the stolen goods or services, or chargeback cost, which your merchants have to go through. Nobody's happy about that. And if you're a merchant, I have been in the past. And of course, as the fraud rate grows, especially in the tough economic times, depending on the industry, your fraud rate is going to go up anywhere from 2 to 7 times. You need to hire more people to address to that resource, especially in the tough times, right? And the biggest of all, which is very difficult to put some quantifiable value on, is the customer lifetime value impact. Nobody is happy when they want to do a transaction and it's lost. Nobody's happy. They're not going to come back and say, oh yeah, I understand, depending on the transaction what they are doing. So when as an organization, you look at the total cost of fraud, it's combination of your fraud losses, your tools and headcounts, and also the customer lifetime value impact. So this is way broader than the budget or budget issued or budget cut for your own your own group, which may be heading this whole initiative or which may be a part of this initiative. So thinking beyond the fraud rate, here is another slide from Gartner, courtesy Gartner. So we plotted this on XY scale. On the right-hand side, what you're seeing is the fraud rate increase depending on any situation, right? Maybe somebody got hold of your cards on dark web or some challenging times. And on the y-axis, what we have here is the total cost of fraud. And as you can see, when the fraud rates start increasing, the total cost of fraud also starts going up. It's logical. This is just because of the number of fraud rates and the false positives that we are seeing in the industry. It's a very general trend. So idea of some of the companies who started using graph databases is to find an optimal zone, what you can see in the graph in the middle, where you can reduce the total cost of the fraud and you can also reduce the fraud rate. The idea is to jam it over there. And graph databases are playing more than fair role to make that happen for the companies. Some of you may be aware of graph databases, others may not be. And what I will do is I will also take you through what a graph database is, probably spend some few minutes over it. And once I'm done with that, we will go into a demonstration. Before we go and really jump into the graph world, let's look at the cross-industry scenario. Fraud, it's a nice word in English lexicon, right? But it's not a copyright of financial institutions. This is happening almost in every industry. Well, I would say I can be sure it's happening in every industry. Here are some examples. Insurance fraud, right? Your worker compensation frauds, car and home frauds. On the telecom fraud side, there are some people picking up devices or some rings or some groups picking up devices with no intention of paying them back on the monthly installments or paying services on top of it. There are groups buying SIM cards in bulk and creating fraud or spam rings where they are ringing up your cell phones to sell you the things which you probably would never like. Anyway, that's a waste of money, waste of bandwidth. Similarly, in the financial fraud side, I can keep on going on this list, and this, real estate will run out on this deck. The most important ones are the credit card fraud, your anti-money laundering scenarios, money laundering scenarios, and counterparty risk. And of course, in health and pharmaceutical side, we hear it almost every month about prescription fraud, opioid frauds, claims and billing frauds. And similarly, license key frauds for your softwares. Rideshare companies have their own challenges with the frauds, whether they are related to overcharging or undercharging or taking wrong routes. In a nutshell, the idea here is to see what is that Graph is providing all across these cross industries that everybody wants to use Graph for fraud detection. Some of you might be using it. Some of you might be totally new to it. So let me take you through what a graph database is. We won't spend too much time on this slide, but if you want to know, or if you want fresh or a beginner, I will suggest you to reach out to us. Now, here is the evolution of databases, and most of us can recognize on the left-hand side is a relational database. So the typical rows and columns, ledger kind of look, primary key, foreign key. These are amazing technologies when it comes to transactions, and they have rigid schema. But lately, and when lately means few decades, what we have been finding with the advent of big data is that relational databases were not up to the mark. They were not able to scale to big data. The cost was running very high. The licensing model was a bit weird. So that's where we had the big jump in NoSQL graphs, NoSQL databases. And that's the key value store. Very useful, highly productive. We all have used it in the past. Fluid schema, poor performance on the simple transactions though. Poor performance on deep analytics and high performance in simple transaction. So welcome to the world of Graph, which is beyond these two. And not that we replace each other in every situation, absolutely not. But in the context of fraud, Graph databases stand out. And it doesn't stand out because I have a circle there in terms of rather than rectangles. This is a very different storage technology underneath. Imagine a world, let's build on a small case here. I want a list or a data point of customers between age of 20 to 30 who live in certain zip codes, right, have bought from us more than 20 times and trying to attempt a transaction using a new credit card, right? I can make up any scenario that I want to use for my fraud detection, right? It's technically, in other words, what we can say, this is an ad hoc query. Now, anybody who has worked on RDBMS will know this is very challenging to run any ad hoc query on the relational databases. Either they have to be indexes, or you run into the beautiful join problems, right? The inner joins, the outer joins, the upper joins, the lower joins, this joins and that joins. You turn millions of rows into billions, and then you put a filter criteria on top of your joined rows to get to the information what you need. Extremely wasteful exercise, and that's what pushes the cost up. Graph databases on the other side, imagine them as a location in your memory space, where each customer is related to all the links, all the edges which comes out of it as another list. And that list connects to another list, which is a node. Another list connects to another list and to the list. So basically what I'm trying to get at is not a list combination here, but trying to tell you that we do not have a joining problem. We hop from one memory location to another. And that is what gives us an advantage at times of thousands of times faster than RDBMS. It's just the way data is stored internally. It is very different. And our ability to fire ad hoc queries doesn't matter to what level you want to go comes into the picture. And of course, this data is semantically related. As you can see, the lines and the edges are very entity-based. Depends on the semantics of your use case. So you have a good distinction You don't have to create distinction like what you do in RDBMS, where the logical model has to be different from a business model just because of normalization. These are basically overlapping terms. So easier to set up, easier, much more performant, and easier to navigate through. And that's the advantage of graph databases. We will build upon some more cases on why this is useful for fraud detection. So let me take you to the 2 reasons before I take you towards the demonstration of our product. You remember, I just told you a few slides back that we have total cost of fraud is combination of fraud losses, headcounts, and customer lifetime value impact. Now, fraud losses, the reason you were having fraud losses, which is such a high rate earlier, because you have the data already available to you. When the fraud has happened, you already know it is somewhere in your data set, but the challenge has always been where to start. There are billions of combinations. The technology doesn't come to your support. The joins are not helpful. So if you have a technology at your hand which can navigate 5, 10, 20 hops down in your data set without a performance hit, and comes back with exposing the hidden pattern inside your data set, which can make your machine learning models helpful or can run some very advanced graph algorithm analytics on top of that, that's definitely going to cut down your fraud losses. Second is your reduction, reduces the manual fraud processing overhead. What happens in the scenario of inability to do multi-hop like analysis or go deeper inside your data? You build tribal knowledge inside your firm where some people are very good at finding the fraud and they have a certain way of doing it. Not everything can be documented. The new hires have to be trained. They take time to ramp up. You need more and more of them. Individual performance cannot be matched, but you have a technology which takes away at least the link analysis part of your workflow and automates that. That definitely brings automation and reduce the effort which will be required when you need to scale and you bring in more data for fraud detection. And of course, complementary to that is that anything which can help you reduce losses on the fraud side, also because of deep link, also has capacity to reduce the false positives. And that's like directly proportional results. So that's why the graph databases, especially the one like TigerGraph, which are highly scalable, comes into picture and give you a reason enough to experiment with them. Second use case is that graph is no one-trick pony. It's not just for deep link analytics, which I have been used probably this term 5 times already. Your anti-fraud landscape consists of various different teams. It's not one team effort. At the bottom, some try to detect fraud, others prevent it, others try to respond it, some work in the combination of it. Your internal company teams may be set up differently, but at the core of it, if you see the bottom of the pyramid, there is a core technology group. The core technology group, the most important ones of them are infrastructure and your enterprise architecture. Everything has to fit into your enterprise architecture with a minimum possibility of deviation from it. You have machine learning teams who are working on feature extraction. You have data science groups. And of course, then there are in the middle of the pyramid, you have fraud and modeling groups whose responsibility is to develop the models. They may not be machine learning models, right? They may well be, these may be statisticians, domain experts, people with the rule and playbooks, expert in credit fraud behaviors. They also get benefit. They also get the benefit of the graph database. And of course, the operational group on the top, the guys who are eyeballing every situation which emerges in the field. They are looking between the link of various different homogeneous and heterogeneous data sets to make sure what has been flagged as your system as a fraud or a probable fraud actually is. They are manually trying to reduce that work. They are coming up with the new rules. So the reason I have put this slide over here is to give you a view that when you have a graph database, all of these groups has to gain from it. The value that graph database provides fall in every category, from infrastructure to the analyst who actually do hands-on processing on your data set. We form a backbone of your technology stack. And of course, we play around very well with all the other existing technology in the world. So going for the graph, one should not be concerned that how would I get others on board? It's actually relatively simple. Once they see it, they see the working demonstrations, they see the value in it. Now that being said, let's focus on a demonstration. In this demonstration, I will take you through a couple of probably 3 or 4 use cases, and they are involved with respect to whatever trends and trends that you have been using inside your company. It could be as simple as reputation list. The reputation list is that you have list of existing fraudster, you have their phone numbers, or maybe these are merchants or credit card holders or account information, their phone numbers, email addresses, maybe IP addresses, device IDs, and feature extraction, the one which your machine learning technology use. And I would also show you later in my deck some unique ways of fraud detection just based on the graph technology itself. And of course, on the top, I'll also show you visualization demos and some rule-based fraud detection techniques. So with that, let me take the liberty of switching my screen here and take you to a demonstration. So we have limited time here, and capabilities of our product are enormous. What I would say is that if you have something missing, or if you find something missing, either ask a question or feel free to reach out to us for separate demonstration on it. So I will not touch on too many capabilities inside the product, but rather than that, I'm going to focus on the use case over here. This is Graph Studio, what you all are looking at. And in the Graph Studio, of course, you can design your schema, map the data. Your data lies in various different sources. You need to bring it in from Kafka, Sparks. Of course, the loading of data is important. The ETL tools are important, how the ETL connections are made, and exploration of the data and writing the query. Capability of TigerGraph, I will also explain around in the future slides why these things are, all of them are so important. But let me focus on a rather straightforward, simple, but very powerful use case. A lot of the use cases that we have been seeing around the industry are focused around a few of these nodes. Now, we have a user. You can say it as an account. As you can see, there are all the attributes possible on a user. He does a transaction. So beauty of the transaction is that there has to be 2 accounts on a transaction. The user can do it, or you can receive a transaction, or he can transfer a transaction. Very interesting term, transferring a transaction. Well, how do you do that? These days, most of us use device tokens. What could be a device, a PDA, maybe my cell phone, my laptop, or some POS sales system. It could be anything, right? And payment instrument, maybe I use check or email or credit card. All those sources, combination of various different attributes. I'm sure in your use cases, those who are coming from this world of fraud detection, you can look at it and you can say, hey, listen, I can add 40 more attributes to it. So if you can add it, we will take it. We can definitely handle as many attributes or vertices you would like to throw at us. With this, let's focus a little bit on the size of the data. So I did talk about graph databases, right? And what is the value of graph databases? Now let's talk a little bit about the value of database like TigerGraph. We are a distributed graph, which has an MPP scale. What does this mean is that your data set can be as big as you would like, right? Theoretically speaking. And we already have terabytes and hundreds of terabytes in production. And this can be distributed over various different machines. So your data set isn't the challenge. What I'm showing you is a very straightforward data import, which include almost 1 billion vertices, 4 billion edges. We got 80 million payment instrument already preloaded into the system. There is a device tokens and users and 800 million transactions. So this is a fair size data. I would say this is a mediocre database. Data size. If you want to increase it by 1,000, absolutely doable. And this is running on a commodity server, 64 gig, 16 core. With that, let me take you to write queries. But before that, I will just quickly give you a glance of loading of the data. So you can do mapping of data. You can bring data from outside. You put it inside your nodes. Once you put it inside your node, you load it. Billions of them already in. So now let's move on to what can be done on top of this set of database. I am going to as I'm explaining this, please keep this in mind. When I explain a particular kind of algorithm, depending on what technology you use right now, I would like you to add a complexity factor on what it would take you to do this in existing technology. What kind of hindrance? It may not just be hardware, it may be just time to do it, right? Writing those queries, slicing and dicing of data. So here I am taking you to a multi-transaction scenario. This query is motivated by detecting money laundering activities. And what this is going to do is that as a transaction comes in, as I showed you, billions of records already into the system, this will find, as we know, transactions have senders and receivers. This will go to both senders and its receivers, find the network with whom these senders and receivers are transacting based on payment instrument and devices, go to four hop deep on both sides, and try to find a circle, if there is any circle between these people who are transacting. So here we go quickly. 1, 2, 3, 4, 6. I'm putting a transaction ID. I want you to remember, I showed you 1 billion records, 4 billion edges in the system. There is no caching involved over here. And we run this query, and here comes the result with a network lag and a browser display in a matter of milliseconds, telling me that this transaction and 2 users between 2, 3 hop down has a circle going from one network to another. Now, what could this mean? This could be a money laundering scenario, or it could not be. What about putting in some kind of condition that it has to be more than $200 or $500, or the date-based proximity on that? It has to be on certain dates. This feature can be useful for your analyst to start looking into it, eyeballing into it, or you can feed this circle as a Boolean operator into your machine learning algorithm and see the accuracy go up. There is a circle here. Maybe you want to do it at 2 or 3 different hops. The idea is not to preach to the choir here. If you are from anti-money laundering scenario, or, from money laundering or anti-money laundering world or credit card fraud detection, this may not be a news for you. But the focus is the speed and scale at which the system operated. Matter of milliseconds, it comes back, shows you the value and the interlinkages. Above all, this is not just about the visualization. This is not about the UI, a pretty UI showing you circles and lines between them. The value lies in the output, what you get. This output can be integrated into your application layer using JSON. We have a shell. We have a shell too, Linux shell, on which you can operate out of. So there are various different ways you can work with this, whether the data science team can directly import this data into their systems. With that, let me take you to another case of same sender and receiver. The use case here is that whether a user conducts a fraudulent transaction for themselves via a fake account, how would you know this is a fake account? Of course, there is a reputation list. Maybe you can see that there is overlapping email addresses. Or another way of looking at it is that guys who are transferring money using same device ID. So if I'm doing that activity from my one account to another, to third, to fourth, I may be using 5 or 6 different device IDs which I may have at home. Or maybe if I'm sophisticated, I may be overshadowing that in some other way. So the possibilities are endless here, the path which you can follow to get to your result set. Again, tons of transactions, and I'm going to put same transaction here and say if there is a same sender and receiver. As you can see, nothing is crossing over, so we are pretty safe. This guy hasn't been doing any kind of money laundering on his data set. We can, similarly, there are various different possibilities of finding what is the money which has been transferred out. Like here is a use case where maybe your modeling group wants to know that how much money has been transferred out of all the connections with whom I work. Here they give a user ID. I gave 1, 2, 3, 4, 5. And between these 2 dates, find me all the money which transferred between them. Of course, it's a graph structure. Output is here. It's a transferred amount is 70, 76, whatever the unit is. Now, the flow here is not just the speed and the scale, the ease of development. What you have seen right now is written, a business logic written inside a G-SQL, which is our proprietary programming language, very much like SQL. So with that, what we can do with such a system, with what ease we can get and produce the output, is totally bound by your and my imagination. You can write any kind of business logic and you can get away getting the wonderful results in a matter of very, very short span. I've been using a single account holders here. You can use 100,000, 10,000. Using the right piece of hardware, you can still bring this response time into seconds, sub-second levels, or minutes, depending on what kind of hardware you want to utilize. So the idea here to show you is that all of this is possible. The ease of navigation which graph structures provide, especially when your data is stored inside graph structures, it becomes much more simpler and easier to get these kind of results. Imagine doing this into your RDBMS and NoSQL world. You need to bring that data out, slice and dice, convert it into various different formats, and still you will end up going 1 or 2 hops down. What do I mean by that, going 1 or 2 hops down? Let me take you to exploration. And over here, very quickly, I'm going to pick up 5 users, random users. And I'm going to double click on it, and you would see everything which is related to this user. Right? Now, I don't want you to focus on the visualization. Please keep the data model in mind. Visualization is just a byproduct of our tool. The power of the system lies its ability inside its engine, the graph engine that we have here. I double click on other user, it's his transactions, and triple click on the user and transactions, and we get more details out of it. And as you can see, we can keep on going and growing the system out. What is valuable over here is that more and more we expand, higher chances of this data set start being connected. That's exactly where the value of hidden pattern lies in the system. From this user on the left-hand side to this device ID, how are they connected? That's connected by a shortest path between them, 1, 2, 3 hops down. So what happened over here is that you don't have to worry about how this data is interlinked and connected, because you can get from one point to another using some basic graph algorithm, and because the data is stored internally in a highly interconnected way. The biggest advantage of this kind of scenario is that when a fraud takes place, as I was telling you earlier, is that you know where to start. You don't know how to enter into that all data set. You don't know how those hidden patterns work. And that's where individual capability comes into picture, that some people are expert at it and others are learning it. With the graph database technology, it's much more easier to find all these links together. Let me take you to another case here. And under this case, what I'm going to do is show a path between 2 users. I'm going to say, show me the minimum path, how this user and these 2 users are connected with each other. Show me just 1 hop. Okay, they're not. Let's go 2 hops. Okay, so now we start seeing that there is a pattern emerging. We can see that they transferred money between each other using a device ID. So far, okay, there is no red marker. Absolutely not. Let's start increasing this size. 3, nothing new comes up. 4. Okay, here we go. Something interesting. We see many more paths between these guys. As I change my display, of course, there are many things you can do over the system. Here is an interesting pattern in between. Why are these 3 users on the left-hand side attached with this device here, which I'm moving? Why are these 3 users using the same device? What is the chances? What is the possibility? What is the need? So there are various different ways how can you find and explore newer paths inside your data set once you start exploring it using the graph, visualizing in the graph way. So there is something for everybody in your team who are associated with the anti-fraud landscape to get value out of the system. Now, you necessarily do not have to use our UI. As I was showing you, this is all JSON output. You can take this output into your own visualization tool, into your own UIs or Tableaus or Power BIs, and you can perform your operations out there. But you can still get these interlinked results together, and you can play around with it. So that's another strong use case for graph databases. Let me take you back to the deck and walk you through art of the possible here. So what just happened? I saw a visualization, we saw some use cases, but what is the value it holds for you? Of course, except from the technical side of it. Now, what it can bring to you is that it can turn your T plus day system, T plus 1, T plus 2 system in a matter of seconds. I'll give you a very basic example of expanding the list of probable fraudsters, right? You have a list of fraudsters, you have the PII information. Some of the companies, how do they operate today is that they will look into their databases, they will get the list of all those known guys, they will pull out their PII information, maybe their IP addresses, search with all of them, search with all of them, and then go down into the database again, pull everything which is related to these items, and eyeball these things manually and find a new pattern for fraud. Maybe 6 things match, this guy is a fraudster. You may not have exactly this process. Maybe you have already automated some part of this process. But broadly, a lot of people in the fraud detection world are still doing this manual process. They will not agree this is manual because there's a lot of technology, data is stored in technology, and they are firing SQL queries on top of that. But eventually, this is what it is. You are still using, some of them are still using older technology. So what happens when you start using graph databases to that workflow? I was showing you as I was double-clicking on any node, all the related information was coming back. Let's say you have a fraudster with X phone number, and now you look up or double-click on that phone number. All the people who are associated with that phone number is going to show up. Similarly, you can go one by one with all the PII information, start pulling this information out, get the cluster of it, run a similarity detection algorithm, which is out of box with our product, and say, if a name matches, 0.1 score. If a zip code matches, 0.5 score, add 0.5 to it. If a phone number matches, 0.3 to it, social security matches, 0.5 to it. Come up with some kind of weighing mechanism, automatically joining these new data sets together, which you have found, and put some threshold on top of it. Anything more than 0.9 is definitely a fraudster. It's the same guy. It's just using a different address. Anything more than 0.5, let me eyeball it. Let me have a look at it. So when you start implementing graph databases, you do not have need to do all these manual processes, as I was showing earlier. Deep link, everything gets together, join these steps together, and you can do all of them in one single query. So that was one of the examples which I showed you. Saves companies tons of time. Let me take you to the other part of it. A lot of times people say, okay, you know what, these reputation lists are very static. They're not dynamic, not changeable. People can generate fake data. Yes, they can. That is very true. But let's look at it another way. One person who has been marked as fraudster has done many fraud transactions. So that transactions have something on it, maybe device IDs, maybe the amount, maybe a pattern is existing in those transactions itself. So what you're going to do is that bring all the data in together, fire shortest distance algorithms between the new transaction which is coming in or new data point that you have found. Just fire the shortest distance algorithm as I was showing you, and let the system figure out how are these guys related. You don't have to think or put a rules or a logic about how to connect X, Y, Z. Maybe run a similarity on top of it, and there goes your results. The biggest benefit of doing such kind of things and what is possible today with the graph databases, and these are the mundane ones that I'm describing, the best one is yet to come, is this turns the whole system real time. Now the new entries you have found, you don't have to reinsert and refire your algorithm to see what impact has happened. You can directly insert this information into your database because the graph databases, especially TigerGraph, is exactly real time. You have bring in your tribal knowledge and you have make it as a part of automation for you. You have reduced the false positives because now you can go much more deeper and you can find all the information about it. So all these advantages comes in when you start going graph route, and that is possible today, which wasn't possible earlier. I will give you also some lessons why this is possible now and which wasn't possible a little bit early. Before that, let me give you some really advanced algorithms which are happening and which is possible into the system. Now, here is a very good example of something which you may not be able to implement with other techniques possible to you right now. And let me give you a big idea of what happens behind the scene. You have millions and millions of credit card holders, and they're doing transactions. There are hundreds of thousands of merchants. Now, is it a possibility for me that I can find communities of these credit card holders based on some habits? And what could be a some habit? Maybe they are shopping at same merchant. Maybe they're living in certain zip codes. Or maybe they have a certain age group. Their email addresses are matching up, all from Gmail or some from Yahoo. Based on all these things, can you turn them into hundreds of thousands of communities? And if you can, the second challenge would be, now you can do this gaming, you can do this clustering also on unsupervised algorithms too. Now the challenge for you would be that, okay, what do I do with these communities? Because some of these communities have the fraudsters already in place, which I have planted in them, because I knew these are flagged as fraud guys. Now, some communities may have a denser fraudster population, others may not. They might be credit card holders, they might be merchants. What if you can do page ranking? And for those who don't know what PageRank is, named after Larry Page, the idea is if a node or if a web page is being referred by many different pages, its ranking goes up, and when it refers to somebody else, its ranking goes up. So there is an interconnectivity angle for this page ranking algorithm. And you run a page ranking algorithm on your credit card holders and find out who are the highest page rank credit card holders in these communities, average out your credit card holders based on these page ranks, and find and target the highest, degree of, let me place it this. So find those people who are, find those communities who have the highest average page ranking score. Now, the advantage of these kind of systems is that if the fraudsters who are in those kind of communities have the highest chances of making impact. So there are various different unique combinations possible. And when I said initially that you cannot do this with the standard technologies which are out there, not that you cannot implement it, the cost of doing such things is extremely high. When you use graph database with the structures that we have, it becomes much more simpler, relatively easier to implement those algorithms. Can you do it in milliseconds? No, of course not. But you don't need days to implement such kind of system when it comes to graph database. So there are different examples of merchants. You want to do merchant analytics. You want to join merchants together based on the people shopping at that level so that you know where the frauds are happening more, whether these are sports good facilities where there are more fraudster combination, or whether these are retail shops where most of the fraudster groups are falling. So there are various different ways, and there are a lot of possibilities when you structure your data inside the graph. More and more companies are realizing this, and that's why they are implementing graph as a prime element for their fraud strategy. That being said, I think we covered a lot of the topics over here. I would like to take some lessons. I would like to present some lessons from the top implementation around various different companies, starting from the bottom left. Why is the time right now? The time is right now because technology like TigerGraph is scale up and scale out technology. You can run these algorithms on the kind of data set that you have, millions to billions to trillions of data sets. So you can run this algorithm in a graph way using our technology in a matter of, depending on your hardware prescribed time, days, hours, or minutes. So that's possible right now. Earlier it wasn't. So if you have tried something in the past, didn't succeed because of the memory limits, I would say try it again. Let me bring the second point, total cost of ownership. That is extremely important. It's on the middle and the right left. You would like to do something like this, but it has to be well under your budget. So TigerGraph technologies come with which has a very high compression ratio. We do not use all the kind of data size that you have. We compress it down into your memory. It's probably 40 to 60% compression ratio. That brings down the cost of your hardware. Lesser CPU power is needed, and you can have higher QPS on your data set, and you may realize that you don't have to put all the data inside the graph. MPP system, extremely important. Very, very important for you to have an MPP system when you're running fraud detection algorithms on graph. And the reason for that is that you want to finish it soon, right? And when you run graph algorithms, your memory consumption is going to go up. You need more cores, more nodes, and these are performance-intensive algorithms like SageRAM, community detection. So you need a system which can make best use of all the hardware available to it at that time. Similarly, as I was previously mentioning in one of the examples, it's a real-time system. As you find your findings, and you push it back into your database. It's a database, it's ACID compliant. And deep link multi-hop analytics. So if you're choosing a database or a technology where you cannot go 2, 3, or 4 hops, you're investing money, on the wrong tool. The whole value of graph database is your ability to go 5, 10, 20 hops down your data sets. Don't think of 5, 10, 20 hops as hierarchies. That may lose its relevance, but there are interlinkages. Go 1, 2 hop down, back up again, 1, 2 hop down. Think about it in that way, and you would see the value of 5, 10, 20 hops when we say that it is achievable in our technology here. Above all, this is an enterprise system. We are being used at 5 top banks in this world. We are already being a core part of their fraud strategy. So by the capitalization. So if you look at those 5 banks and the reason they have chosen graph database, and if you're thinking about, does this fit into the enterprise model which we have here, then answer is yes. Our security, we integrate with the LDAPs and all the internal systems. We have a multi-graph capability to segregate the data sets so that one group cannot see the other group's data. And we have encryption data set for your, so all is pointing toward a 3rd generation graph database. So when we join all of these things together, we find out that this is a generational shift from the earlier existing technology. So that's why we like to call TigerGraph as a 3rd generation graph database with combination of all these things. And the lessons, and these are the top lessons learned from the implementation. I have shown you cross-industry setup. I have shown you why fraud institutions, why financial institutions are using it. What are the possibilities you can use our graph database for? And when you join all of these together, and if you are curious and you want to learn more and you want to try something out, I would say, please reach out to us. I will be happy to set up further discussions with you, take it forward from this 40-minute stint, which I have done very quickly. With that, let me hand it back to you, David.
Thank you, Abby. That was fantastic. Thank you for walking us through as many queries as you did. That was more than I'd expected, and hopefully everybody found that interesting and informative. So a couple of questions have come in through chat. Before I go to those, again, just for everybody who is listening to this webinar, we do want to make this as interactive as possible. So feel free to submit questions either through the Q&A button, or you can do it through the chat button. So a couple of questions we've had so far are, how does TigerGraph integrate with BI tools and other data sources? How does TigerGraph integrate with BI tools and other data sources?
As I was showing you earlier, the JSON output what we have, you can always use TigerGraph output and integrate with the JSON input from your BI tools. You can export data in CSV files. We have JDBC drivers for you to pull the data out and take the data in. And on the other side of various different data sources, what I'm going to suggest you is that you can reach out to us for more details, but we can integrate with your Hadoop system, your Sparks. We can all integrate with your, anything which is compatible with JDBC, flat files, XMLs, RDFs, everything is possible.
Cool. Another question was, is anyone using the solution you showed?
Definitely, I cannot take the name of the customer. As I was saying, the top 5 banks in the world are already using this system. On the financial services side, we have people already using this in healthcare, which is a very big business for us. And if you ask me, where is our, core focus, then I would say half of the use cases what we see in the industry are related to some sort of fraud. Say this be financial fraud, say this be healthcare fraud, say this even be a ride-sharing fraud, or a software-related licensing fee fraud. So among all of these cases, that constitutes around 50% of our business. So of course, I can't take the name, but yes, absolutely.
Okay, another question I see.
Used widely.
Right. Another question is, you said you go 5, 6, 10 plus hop deep queries. Why is an ability to go 10 plus hops important? You touched on this, but if you can just reiterate, I think.
So sorry, if you can come to the last part, why is or
why is an ability to go 10 plus hops important?
Yeah. Now that's a very subjective. There may be scenarios where this is not important. Absolutely not. But then there are scenarios where it is extremely important. And when I say 5, 10, 20 hops, you have to think of the perspective of not going on 10 hops because let's say you don't even have that many elements in your schema. The hopping means going from one data point to another, and there are edges which have directions, and they are bidirectional, unidirectional with reverse edges. So you can go up, down, down, up, left, right of your nodes, and they are all counted as hop. Why would you do that? Maybe you just want to do averaging of something. Maybe you want to calculate the money flow, Mr. A transfer to B, B to C, C to D, D to E, and you want to do some kind of calculations on top of that, whether it's a fraudulent activity or not. Is there a cycle in this transaction? What can be possible is that also on a credit card fraud side, when you have devices, when you have IP addresses, you want to make sure this these devices are being utilized for what is the average rate or trust factor on a device. So you probably want to calculate all the transactions which went through that device, which could probably be 30, 40, 50, and you want to sum them up to put some kind of calculation on top of it. So there are various different reasons. There may be scenarios where you don't have to, and then there are where you have to. So the nutshell, the question here is not how many hops you can go. The question also is hop with how fast and quickly and swiftly you can execute that.
Okay, thanks for that. This question came in through the Q&A tab. How to use this software to report a large number of orders / trends?
Large number of orders.
Orders or trends.
Okay, so this probably has to be formed a little bit differently. I'm not sure I am able to fully grasp this use case, but let's say if there are a large number, then, okay, so one possibility is that you probably don't want to look all those orders and trends on the same screen because that doesn't make too much of sense. It takes up too much real estate. So you can export the data out. Whether it's 1 entry or 1 million entries or 10,000 using your JSON to CSV files or whatever output format. You can import data. So similarly, you can export data out from your queries. So whether they're small in number, whether they're large in number, doesn't matter. When you're talking about trends, if you're talking about some sort of recommendation, that's also a very strong use case for graph database. So I'm not sure fully I understood the question, so I'm giving you 2 or 3 different answers. So if you're looking for suggesting trends to the people, then yes, there are use cases around recommendation systems too, from which you can calculate the trend based on somebody's pattern of behavior.
Sounds good. So that question was submitted by anonymous attendee. So if you're still out there, anonymous attendee, can you let us know if that answered your question? And that's all the questions I'm seeing, Abby. Oh, yes, the answer is yes, you answered my question. Well done, Abby. You guessed.
All right.
Your responses spanned, at least one of them hit the nail. All right, Abby, I think in the interest of time, maybe we can move forward and wrap things up.
Sounds great. So let me move it.
All right, great. So thanks again, Abby. That was a very, very compelling presentation. And hopefully people in the audience found it useful. If you have more questions that we haven't answered, then please join our developer forum. The URL is shown there. If you want to join our developer chat, you can do that too on the Discord platform. And then tomorrow, or indeed any Thursday, if you want to chat one-on-one with a subject matter expert, you can do that Thursdays, every Thursday at 11 a.m., typically for about an hour, depending upon how many people are there. One of our SMEs will be looking out for your questions and happy to respond to them. Next slide. Some additional resources. So today, Abby predominantly used our developer edition version of our software. We have a cloud version, and that might be the easiest way for you to get started with Graph and indeed TigerGraph. Why? A couple of reasons. Number one, it's free to get started, and it takes only 5 or 6 minutes to create an account and begin to use cloud. The second reason why it's a good way to get started is because we have pre-populated our cloud platform with over 20 different starter kits, including the one just shown, and pre-populated with schema, with data, with queries. So you don't have to look at a blank screen and figure out what to do. We've already, got some things there for you that can help you to get going. We have our test drive online demo where we show the product in different use cases, across different use cases. We have our developer edition, as I just talked about, and as Abby showed, and we have our Graph scripts, which we store on GitHub. Next slide, please. So that really brings us to the end of the presentation. You always like to end by talking about our upcoming events. We have one tomorrow night. It's part of our Graph Gurus Comes to You workshop. We have, until the pandemic hit, done these in person. We will start those up again shortly. But for the meantime, we're doing one online. And it's with Galvanize. Many of you are familiar with Galvanize. They have about a dozen locations in the States, and this is with them. It's going to be a 2-hour workshop. It starts at 4:30 Pacific time. And if you want to join, we'd love to have you. We have currently 85 people registered, but there's room for more. Please sign up at that link below. Again, it's tomorrow at 4:30 Pacific. And then next week, our next Graph Gurus episode, number 35, will be on Wednesdays. Please note the time is a little different. It will be at 11 o'clock Pacific. And the topic is the new functionality in our 3.0 release. The title is How the New Functionality in 3.0 Will Help You Connect the Dots Even Better. And hopefully we'll see you at one or both of these online events. And so last slide, please, Abby. That brings us to the end of the webinar. I found it very informative. Thank you again, Abby, for giving an excellent demo. Hopefully, audience also found it informative. Reach out to us if you have more questions or you want a demonstration tailored to your specific needs. We'd love to do that. But for now, that brings us to the end of today's webinar. We appreciate you had many things to do and are flattered that you've chosen to spend the last almost an hour with us. Hopefully you found this to be an informative event. We look forward to seeing you at a future one. Please stay safe, and we look forward to connecting with you again in the near future.